Hi, sir.
Okay, we'll wait a couple of minutes. Please mute, or I'll mute you all, and then if you want to speak, right, you can unmute. Okay? Okay, we're recording now. Do you have questions about the previous lectures? You can type as well, right? Or just unmute yourself and tell me. Do you have any questions about the previous material that you covered online? Okay, that's a no. Then we can start with the new lecture. Let me share. I need to share the screen with you. PowerPoint and share. Can you see it? Somebody tell me if yes. Yeah.
Yes, we can see it.
Okay, great. So today we're going to talk about. 1 second. Why is not doing what it's supposed to do? Escape. Stop share. 1 second. Share screen. Maybe I have to share all screen. Okay. Can you see the slides?
Yes.
Yes.
Great.
Yes, sir.
Perfect. So what you guys learned in the last class, basically the last few lectures that you did online, particularly the last one, the data manipulation using SQL, insertion, how to insert, how to delete, how to update records in a relational database. You also looked at retrieval, also known as querying. Particularly, we looked at projection, selection, duplicate elimination. So using the keyword distinct, arithmetic operations on projected attributes, and string pattern matching using the like operation. However, all of this was done from a single relation. Today, we're gonna talk about renaming attributes and relations. So see how do we apply the rename operation we have encountered in relational algebra. We're gonna talk about joining relations, so selecting records from multiple tables at the same time. We're gonna talk about sorting and grouping and aggregation. All right. So this is the schema we're gonna play with. We have father-child, right? That's a table. A mother-child is another table, and these contain information about people and their fathers and their mothers respectively. Yeah, and then I have a table called person, which has the name of every person in the database, his or her age, and the income, right? How much money they make. Okay. Now I have two foreign keys from father-child to person. So the attribute father references name of person, and the attribute child references name of person. Same thing in mother-child. Yeah, two foreign keys to the person table. Okay, the primary key of person is name, and for father-child it's father and child, and for mother-child it's both attributes mother and child. Okay, good. It is an example instance of the database. So I have, some people, right, their age and their income here in this last table. I have, information about the fathers of people. So Steve is the father of Frank. Greg is the father of both Kim and Phil, and so on. The same thing for mother-child. I have Lisa is the mom of Mary and Greg, Anne is the mother of Kim and Phil, and Mary is the mother of Andy and Rob. Okay? Good. So renaming attributes. We use the as keyword to rename attributes. Yeah, it's a special keyword in SQL. For example, to rename the attribute name into person name and income into salary, the following statement can be used. Let's see the statement. It's an SQL query. We're saying select name as person name, income as salary from person, right? So we're really saying, okay, rename the attribute name into person name and income into salary as you retrieve records from the table person. Yeah, this will retrieve all the records from the table person. So it's a projection. Here's the query and the table person. And what do we expect the results to look like? A new table, a new relation, which has name displayed as person name. So the name of the column would be person name, and income would be salary. Age remains the same. Okay. Sorry, here we're only selecting, sorry, age would not appear at all because I'm projecting only person name and income from the table. Yeah, so age will not be displayed. All right, good. Please interrupt me if you have any questions. Yeah, either by chat or by unmuting yourself. Okay, that's equivalent to what in relational algebra? Equivalent to renaming the table person into, you know, the same table name person, but with attribute names, person name, and age and salary instead of name and income. And then you project these two attributes, person name, the new attributes, person name and salary. Okay. Very good. Joining relations. Now, this is where things get tricky. So I have two relations, R1 and R2, and a join condition to join these two tables. The same, it's the same semantics as in relational algebra, yeah? So I can do this in SQL as well. So the general statement, the SQL statement to join R1 and R2 would be select a list of attributes from the table R1, comma, the table R2, where you put the join condition. And that would be as if you're doing joining of these two tables based on the condition C. Let's see an example. For example, to find the fathers of all people that earn over 30K. Yeah, so I want to find people that earn over 30K and then find their fathers. The information about fathers is in the table father-child. The information about, you know, the income of people is in the table person. So I need to join these two tables. Yeah, and what is the join condition? It's that, right, I want the income of the children. Yeah, so basically the child is equal to name. So I'm saying select father. That's what I want to project at the end. From father child, comma person, where child is equal to name and income greater than 30. So child is equal to name is the join condition. Yeah, so I want the child to be the same as name in the table person. Let's see the results of this query. I have the table father child, I have the table person. Now the query again joins the two tables based on the condition that child is equal to name. Okay, so first record, Steve and Frank. I have to go and check if there is any record in table person which has Frank, right? So which has Frank as a name. So I have a record which says, right, Steve is the father of Frank, and Frank earns how many? 20. So would this record be included? The answer is no, because, right, Frank makes less than 30. So this one would be excluded. Then I go to Greg and Kim. Greg and Kim, right? So I check how much does Kim make? She makes more than 30. She makes 41K. So she will be displayed, and Greg, right, would be selected, right? Because Greg is the father. The same thing for Greg and Phil, right? So we'll go Greg, Phil, but Phil makes exactly 30, so it would not be selected except once, just for Kim. Then we look at Frank, Andy. Andy makes 21, so we'll not include this record because we're doing inner join, yeah? Frank and Rob, so Frank and Rob makes 15, so Frank would not be displayed. And we get the answer only correct. Is this clear to everybody? Yes? You're still there, right?
Yes.
Okay, good. Just making sure. I see his chat 17.
Yes.
Is there already some questions? Ah, yes. Oh, you're writing yes? Okay, okay, good. So I'll put this somewhere so I can see it. Hopefully it doesn't distract from the, or maybe I'll just close it again and see it open it later. Okay, good. So this is equivalent to what in relational algebra? I have select Okay, select where income is greater than 30 from person. Okay, so that will give me only the people who make more than 30K. And then I join this table person, right, or the selection over person with father child, such that child is equal to name, and then project the name of the father. Okay, good. First questions. Let me see, how do I open the chat? Okay, good. One new message. Yes, okay, very good. So some exercise. We want to write the SQL statement to do the following. Find the mother and father of every person. Find people that earn more than their father, showing their names, incomes, and incomes of their father. So please try to do the first one, to find mother and father of every person. Yeah, I'll show you the schema again. Here's the schema, right? So I want to find the father and mother of every person that I have. Yeah, so try to think, how do I do this? For a bit, and then we'll discuss the answer. Yeah, so I need these information is in these two tables, father child and mother child. Yeah, because I'm not looking at age or income at all. So what do? I need to join these two tables, right? So join these two tables. What is the join condition? Anybody?
Child equal to name.
But I'm not joining father child with person. I'm joining father child with mother child. I want to find, for instance, for Frank, right? I have who, for instance, for, let's see, for Kim, right? I know I want to see that her father is Greg and her mom is Anne, right? So Kim, the second row in father child, and the third row in mother child. So I want to display that Kim has a father Greg and a mother Anne, right? So I don't really look at person at all. I am trying to join the two tables, father child and mother child only. Okay, chat. Okay, exactly. So join them such that, right, exactly, father child dot child is equal to mother child dot child. Yeah. We could use outer join if we want. We'll see when outer join apply. But for now, I only want to show for every person, right, or for every child, their mother and their father if both are no. So inner join. Yeah, we haven't talked about outer join yet. Okay, let's go back to the slides and see how do we do this. Here is it. So I do the following. Select, I want father child dot child, right? So basically pick the child from one of the two tables, father and mother, from father child, comma mother child, where father child dot child is equal to mother child dot child. Yeah, so the condition is that the child is the same in both tables. Yeah. Why do I have to use father child dot child and mother child dot child? Is because the name child is the same. Yeah, so I have to distinguish, right, to give the SQL query engine a way of distinguishing which child do you mean. Yeah, so I use father, the name of the table dot the name of the attribute. Okay, and I can select, of course, mother child or child here instead of father child or child. Any questions? Okay. All clear. Okay, good. Let's do the following. Let's see another way of doing this. So another way of doing this is to rename, do an alias for the table. Yeah. So this is a nice trick that you should learn in SQL. It makes your SQL queries cleaner, a lot cleaner. So I'm gonna alias father child as FC, mother child as MC. How do I do this? I say select set of attributes from father child space FC, mother child space MC. Now this, whenever I refer to these tables, I can refer to them using these aliases, FC and MC, right? So I can select FC.child, and that would be child from the table father child. Father and mother, I can say FC.father, MC.mother, of course, but I don't have to because they're not ambiguous. And where FC.child is equal to MC.child. Okay. Where is the chat? Why didn't we select the MC.child also, right? We could, but it's exactly the same value. Sorry, so I went back to this. Where is it? Yeah. So we could, right? But it's exactly the same value as FC.child. So I will have the same column repeated twice. So I don't really need to do that. Yeah, because I want to just show the child, let's say Kim, and her mom is Anne, and her dad is Greg. Yeah, so I don't need to say Kim, and then Anne and Greg. Okay, good. Type. So the second query is find the people that earn more than their father, showing their names, incomes, and incomes of their fathers. So that involves two joins. Yeah, join with person twice. Let's see why. Okay, so I'm gonna go back to the schema again. Here's the three tables. I want to find, right, the father's, what was the query? Let me write it down. Find the people that earn more than their fathers. Okay, showing the name, their names, incomes, and incomes of their fathers. Okay, so back to the schema. Voila. So I have right now, I want to find, right, so people that earn more than their father. So the information about a person and their father is in the table father-child. Okay, great. Now to get the income of a person, I have to join with the table person, right? Because the income is in the table person. Okay, I need two incomes. I need the income of a father and the income of a child. So I need to do two joins, father-child joined with person to get the income of the child, and father-child joined with another person to get the income of the father. Yeah, so let's see how do we do this. So we want to select at the end the name of the child, right? Their income and the income of their dad. So for instance, for Frank, we need to find, right, that Frank's income is 20, and right, Steve's income is 23, right? So in this case, this record would not be selected because Frank doesn't make more than his dad. Yeah, but for Greg and Kim, for instance, Greg makes 40 again. Yeah, for instance, Greg and Kim, this would be selected. Kim makes 41 and Greg makes 40, right? So she makes more than her dad. Where's the mouse? Here it is. I don't understand this question, Muhammad. Can you please elaborate? What do you mean we can use the statement that we wrote before? You can use your mic if you want. Okay. Until Muhammad answers.
Sir, can you repeat, please, this by using your mouse?
Can I repeat what?
By using your mouse.
Okay, so
what? Telling us.
Yeah, so what do you want me to repeat? Repeat what? So for instance, Steve and Frank, what do we want in this query? We want to find the children that earn more than their dads, okay? So I have to go to the table person twice. Once to find the income of the child and once to find the income of the father. And then only print or retrieve the records for which a child makes more than the dad, yeah? So let's see, for instance, Steve and Frank. So Steve and Frank, right? Let's see the income of Frank. What is the income of Frank? It's 20. What is the income of Steve? It's 23. So does Frank make more than his dad? The answer is no. So this record should not be returned. Let's look at Greg and Kim. How much does Kim make? 41. How much does Greg make? Right? Greg makes 40. So yes, Kim makes more than Greg. So I should return Kim. Her income is 41, and the income of her dad, which is Greg, is 40.
Okay, thanks. Perfect.
Yeah, so we'll see now how do we write the SQL statement, but that's what we want to achieve. Where's the chat thing? Okay, so the SQL statement. Let's see how we write it. Here it is, right? I have two joins. 1 second. We have to do joins, two joins, Muhammad, right? We have to do join with, first of all, mother child. We do not include at all. We're not really care about anything related to mothers here. We only care about the father child, right? So we want to say, okay, this is the person, this is his or her father, and we want their income, the income of the person, the income of the father. So I really need just father child, and I need to join it with person twice. Once, right, to get the income of the father, and once to get the income of the child. So let's see how do we write this. So I select, right, something. So I need 3 attributes: the income of the child, the income of the father, and the name of the child from person F. So I'm giving an alias to one copy of the person, father child FC, so an alias for father child, and then person C. So the C represents gonna represent the instance referring to the child. The F is gonna represent the instance referring to father. So here is the condition, the join condition, where f.name is equal to fc.father, right? So basically you're saying the father, in the table father child, we want the attribute father to be equal to the name of the copy of person F. Okay, and then for the child, right? So c.name, the person C, right? The copy of person referring to the child. C.name is going to be equal to fc.child. Okay, so now I've joined this table father child with 2 other tables, person C and person F. Okay, once with f.name equal to fc.father, and once with c.name is equal to fc.child. And then finally, I have a selection condition that the c.income, the child's income, is greater than the father's income. Okay. What am I selecting? What are the attributes I'm selecting? I'm selecting c.name, the child name, the child income, c.income, and the income of the father F. Okay. Questions? All right. Let's run the query. Here we go. Okay, so we don't have the solution of the query, but really what we did a couple of examples in the before we looked at the query itself. Yeah, so we looked at the records that satisfy the condition. Okay. So this is all inner join. I'm doing inner join, meaning, right, I'm not taking any dangling records into consideration. I can also do inner join explicitly. Why do we have 2 person instances? Why? Because I need the income of the person, the income of the child, and the income of the father. Yeah. How do I get these 2 incomes? I have to really join once, right, with twice with person, once for the father and once for the child. Okay. That's why I have the person twice. Other questions, guys? Okay. So I can also do explicit inner join. So given 2 relations R1 and R2, SQL allows you to do join, inner join, right, by using the keyword join explicitly. So instead of saying select blah, blah, blah from R1, R2, where you put the condition C, the join condition C in the where clause, you can do the following. You can say select a list of attributes from R1, join R2 on the join condition, And you can add additionally some selection. So where some condition holds, yeah, different from the join condition. Let's see an example on this. Here's the same query we did, right? Find people that earn more than their father, showing their names, incomes, and incomes of their fathers, right? I can use, right, we've seen it using the select from, right, 3 tables with commas, but I can also use the join keyword. So here I'm saying select c.name, c.income, and f.income from person f, so that's the copy of person referring to father, join with father child, so the table father child, I call it fc, on f.name is equal to fc.father, okay? Because the person f refers to the father. Join, again with person c, on, right? fc.child here is equal to c.name, okay? So copy of person for the child. And then you add the condition that you have, that c.income, that income of the child is greater than the income of the father. That's exactly the same query as the query we've seen 2 slides ago. Okay, and this is inner join. So when I say join on, this is considered inner join. Questions? So we do not need to somehow define F and C before selecting them. So you define them in the from clause. Yeah, so Asma, what you do is you say, okay, you give an alias in the from clause. And once you have the alias, you can use them in the select part, yeah, in the projection part. So you can use it everywhere in the query, but you have to define it in the from clause. So you say from person F, join father child FC, and so on, yeah? So it parses the whole query, right? And it starts with the from clause, and then from that, what is the purpose of join in this case? The purpose of join is to get the income of the father and the income of the child. Again, the income is not in the table father child. In father child, all I have is the name of the person and the name of the father. Okay, so I need to join it twice with person to get the incomes of the child once and the income of the father once. Is that clear, Rina? Okay. Fine. Let's look at natural join. So remember natural join? Who can remind me what is natural join? We just did it in the exam.
When we see same attribute.
Yeah, so basically it's joining 2 tables such that, right, they have 2 attributes that have the same names, right? Or more than 2 attributes that have the same names. And what you do is you equate these attributes, yeah? And then each attribute will appear only once. You can do this also explicitly in SQL using the natural keyword, right, before the join keyword. Okay. So all attributes with the same name in both relations will be equated, and each will appear only once. Okay, so for example, to find the father and mother of every person, remember, right, you have 2 tables, father, child, which has 2 attributes, father and child, and another table, mother, child, which has 2 attributes, mother and child. So I can do a natural join between these 2 tables, yeah, and that would tell me that you equate the child in the first table with child in the second table, okay? And each would appear only once. So I can say select child, father, and mother from father, child, natural join, mother, child. Who can tell me what will this query give me? What is the goal of this query? Anybody?
Father and mother that have the same child.
Yeah, so basically for every child, will show me the father, the name of the father, the name of the mother. Correct? So for every child, it will show you the name of the father, the name of the, yeah. And here we're using natural join, so I don't have to have a condition at all because it will explicitly equate the column child and father child with the column child and mother child. And right, I don't need to here, right, do aliasing or anything because child will appear only once. Yeah, but it's not confusing for the SQL engine. Questions so far? Okay, outer join. Outer join, remember, looks at the dangling records. So records that are dangling will appear. Yeah, so if I given two relations, R1 and R2, and a join condition C, the SQL statement to perform an outer join of these two relations, either left, right, or full, is as follows. You select a list of attributes from these two tables, from, so R1, and then you specify left, right, or full outer join R2 on C, where condition. Okay, so that's the only way of doing outer join. The previous ones, right, were inner joins. So I could use, I had two ways of doing them, either using the explicit join keyword or join operation, or by saying select blah, blah, blah from R1, R2, where, right, you put the join condition in the where clause. In the outer join, this is the only way of doing it, right? So you have to use the outer join operation. Okay, let's see example. So for example, the following query can be used to return for every person, the father, and if known, the mother. Okay, so let's see what this means. I'm saying select father and mother from father child, left outer join mother child on. So that's the join condition that father child dot child equal to mother child dot child. Yeah. Here I'm using the name of the table because I'm not using an alias, and it's the same attribute. So I can say child equal to child. It will be confused. So that's why I use the name of the table. Okay. Now I'm saying select father and mother from father child, left outer join mother child on father child dot child equal to mother child dot child. What does this give me? That's a question. Any thoughts? Will give me for all the fathers, right? So it's a left outer joins. Remember the table on the left will be shown completely. Yeah. So all the records there. So every father will be appear, and then we'll see, right, matching tuples. So based on the child, and get the names of the mothers. And if there is a father for which there is no mother, right, information, I put the mother as null. Let's try to look at this. Yeah, see if there is any examples on this. Here, let's look at the table father child. If I do left outer join between father child and mother child, such that the child in the first table is equal to child in the second table. Steve and Frank, do I have any matching record for Steve and Frank? Do I have the mother of Frank in this table, mother child? The answer is no, right? I don't have the name, right? Frank, right, doesn't have a mother information. So in that case, since it's a left outer join, I will see Steve, and then for the mother, I'll see null. Yeah, so if I've selected the child, the father, and the mother, I'll see Frank. His father is Steve, his mom is null. Yeah. For instance, Greg and Kim, I know the information about Greg and Kim. I know Kim has her dad, Greg, and her mom is Anne. So I would see Kim, the father is Greg, and it's the mother. Okay. Another dangling record in father-child. Is there any dangling record in father-child? No. Right? Only Steve and Frank. Right? That was a dangling record because it doesn't have a match in mother-child. The rest all have matching records in mother-child. Okay. How about the other way? For instance, if I do select, right? Father and father and child and mother from mother child left outer join father child. What do I get? So I'm doing left outer join between mother child and father child.
Mary and Greg will be dangling.
Mary and Greg will be dangling, exactly, right? Because Mary and Greg we don't have the information about their father. So they will appear, right? Mary, her mom is Lisa, and her father is null. Greg, her mom is Lisa, and her father is perfect.
How many columns do we have at the end?
So depending on what you select. So you select at the end, right? So here we're selecting in the query we have, 1 second. Here I'm selecting only father and mother, right? So how many columns do they have?
Oh, we don't have the name of the child here.
Yeah, if I want to select the name of the child, I can just say select father child dot child, for instance, comma father comma mother. Yeah, that will give me the 3 columns. But here in this example we looked at, right, we only have 2. So we'll have the name of the father and then null if the mother doesn't exist or we don't have information about it. Clear?
Yes.
Okay, good. Now let's look at these 4 queries. And we'll see the difference between them. Okay. So I have select father child dot child, father and mother from mother child, join father child on mother child dot child equal to father child dot child. So this is the first query. Okay. What type of join this is? This is an inner join. Yeah. So inner join means what? Means there is no dangling records. So if I don't have the information of right the father or the mother, right, the record will be ignored. Okay. So basically, I only get matching records. Yeah. Records for which I know the father and the mother. Okay. Second one, select father child, father and mother from mother child left after join father child, such that the child is the same. Yeah, in these 2 tables. So what do I get? I get, right, I'm doing mother child left after join father child. So I will get, right, all the records in mother child and, right, as well, and the matching records from father child plus null for father if there are no, matching records. So if there are dangling records in mother child, I'll get null for the value of the father in the table and in the select statement. Yeah, and the results of the select statement. The second one is a right outer join, right? So I'm doing right outer join between mother child and father child. So basically, I will get all the fathers because I'm doing right outer join between the mother and the father. So I'll get all the records from the father, right, including dangling records with null for the mother. Yeah, so if I have a person for which I only know the father information but not the mother, I will get this person, the name of the father, and null for the value one. And what about the last one? Full outer join, what do I get? Folks? Any thoughts? Full outer join? Yes, you get so many nulls. So basically, you get everything. You get dangling records from both sides, correct? So you get, right, it's a full outer join. So you get the dangling records from the father child and dangling records from the mother.
Yes.
Okay, good. So let's see if we will manage to continue with the same link or we have to switch to the other link. We'll see in a couple of minutes. Let's take a 1-minute break, yeah? Relax, stretch, and we're all sitting. And if it doesn't expire, we'll continue.
Sure.
Yes.
They sent a message telling us that it's upgraded, so we have unlimited time.
Okay, great. So then we'll continue on the same link. No inner join. So Edmund, what do you mean by no inner join? The first one is an inner join. The very first query, right? This one is an inner join. Yeah, because right here I'm not getting the dangling record. Okay. The first one is not a natural join because I have the record, right? So I have the condition, right? It would be natural join if I could use a natural join, but I would have to say natural join as a keyword. So here I can say select child, father, mother, from mother, child, natural join, right, father, child. That's it. I can do that as well. Okay, questions so far? We're done with join. We're gonna do sorting now. Okay, sorting is very easy, yeah? So remember the sort operation in relational algebra. We can do the same in SQL. It's a very important operation because we most of the time we want the results of a query to be sorted in some order, yeah? To be represented in some order. Okay, so we use the order by clause to sort the results of a query. So for example, to return the names and incomes of people under 30 in alphabetic order of the names, the following statement can be used. Select, first of all, I need the name, the income, and age from person. So that would select name, income, and age from the table person. I need only ones who have under 30, so where age is less than 30. And then I order by name. Okay, so let's see the results of this. So Andy, 27 and 21 is a match, right? Rob, 25, 15 is a match, but Mary, 55 and 42 is not a match, and so on. Why? Because they do not satisfy the where condition, right? So Mary, 55, 42 does not satisfy the where condition. The age is not less than 30. Okay. Now, I'll get all the records that match. So how it's executed, I'll get all the records that match the where condition, and then at the end, just sort the results before returning them to the user based on name. So basically, I get only 3 records. That's Andy, Phil, and Rob. These are the incomes, right? 21, 30, and 50. Okay. So sorry, I was looking at the income when I was explaining the query, right? I should have looked at the age. Okay. So Andy, these are the 3 records that satisfy the query, having age less than 30, right? These are the only people, the rest are seniors. And then I sort them based on name. So I get Andy before Phil, before Rob, alphabetic. Okie dokie.
Yes.
Just making sure. So this is equivalent to what? Equivalent to tau of name. So I want to sort over name and then project name and income from person after you select those who have age less than 30. Okay, good. Type. We said in relational algebra there is no sorting descendingly, right? So reverse order. However, in SQL, this is implemented. So you can use the keyword DESC, descendingly, to sort things descendingly. For example, to return names and ages of all people under 30, ordered by their income descendingly, the following statement can be used. Let's see the statement. Select name and income from person. That's again right, because I want the name and the income. Again, where age is less than 30. And then ordered by income descending. Yeah, so I want to order by income descending. So again, I had 3 only candidates. So Andy, Rob, right? These are the ones who have age less than 30, and who else? And Phil. So Andy, Rob, and Phil. Now I want to sort them based on income descendingly. What do I get? Andy, Rob, and Phil. Who I get on top?
Rob.
Descendingly, not ascendingly. Descendingly means from the higher value to the lower value. I get
Andy.
So Andy, I have the matching records at Andy, Rob, and Phil. Who has the highest salary income out of these 3 people?
بس ليه فيل مش هي less than 30?
Yeah, right. So age is less than 30. So Andy, Rob, and Phil are the ones who have age less than 30 in the whole database. Now I'm sorting them based on income descendingly. So I want the one with the highest income on top, followed by the ones that has lower income, and so on. Right? So I should get Phil, and then yes, Phil. Right? So I get Phil on top, followed by Andy, followed by Rob. Okay, perfect. Phil, Andy, Rob. That's correct. Exactly. Right, and this is their incomes. Clear? Okay, good. So there's no
But sir,
yes.
here why do we have we're taking the age as being the condition, right? So
Yes.
this is why we have Phil and Rob and Andy. Okay, thank you.
Okay. So now again, remember there's no equivalent operation for sort descendingly in relational algebra. Yeah. So that's just a remark. Okay, good. Sorting. You can sort on more than one attribute, either ascendingly or descendingly. So let's look at an example. I want to return names, incomes, and ages of all people over 40, ordered by their age descendingly and their income ascending. Okay, so I want the age to be descending and the income ascending. The following statement can be used. Select the asterisk from person where age is greater than 40. So select all the people who have age greater than 40, and then ordered by age descendingly, comma, income ascending. So I can have multiple attributes ordered by multiple attributes. First of all, what does it mean, select star from person?
Select everything.
Yeah, select all the attributes. Yeah, select all the attributes from person where age is greater than 40, and then ordered by age descendingly and income ascending. Okay. So let's see the results of this query. Think about it a little bit, and then we'll discuss. So I need to select two guys who have age greater than 40. Okay, so I look at the column age, and I get Mary, Anne, Greg, Frank, Mike, Lisa, and Steve. Yeah, so I get few of these guys. Yeah, so now I need to select, order them based on the age descendingly, and if there are ties within age, I order based on the income. So let's see the results, right? I get Mike on top because I have the highest age. I'm doing age descending, followed by Steve, followed by Lisa, followed by Frank, followed by Mary, because I'm sorting based on age primarily. And then I get Anne and Greg. Both of them have age 50. Should I put Anne first or Greg first? I resort to income and use ascending, right? So I use ascending order for income. So the one with the smaller income would appear on top, followed by the one with the higher income. So in that case, I get Anne, right, first, and then Greg, because Anne makes less than Greg. Okay, so I can combine multiple attributes when sorting and do this either ascending or descending. Okay, so far so good, it seems. Okay, so we can stop here, right? I'll take questions. We'll continue on Thursday, yeah, on Tuesday. So this is I think is more than enough for today. Yeah, we're trying this out for the first time, so I don't want to overwhelm you with too many things. Please read these slides. I will answer. I see that in the chat there's some comments. I'll answer them, but please read these slides again at once more before the next lecture. Okay. Okay, thank you. Right, I hope it went well, and I will post the recording of the lecture on Moodle as well. The midterm grades, we're still correcting the exam. Yeah, we have 160 students, so it's taking us more time than expected. Any other questions? Okay.
Will we have any other quiz?
Would you have any other quiz? You'll have quizzes online, yes. So we still have some sessions online. Face-to-face quizzes will not take place anymore. So most importantly, you have things on the basically on Moodle, right? Any quizzes that will take place on Moodle. Yeah, and then they have the final exam. We'll see where it's at. Somebody asked me, right? So you can leave now. Somebody asked me if you want. but somebody asked me, please answer the email. What was the email about, right? So is it about the quiz, the online quiz? Will the percentage of the online quizzes be higher? We don't know yet. We'll see. We might most likely not, right? We'll just live with the fewer quizzes that we had in the face-to-face sessions. Yeah, but we have to think about this. How do we adjust the percentage if needed? We'll inform you if we do. Muhammad Naji Qadri, right? I'll check my inbox. I don't remember you sending me an email, but I'll check my inbox. What if they have the same age and same income? Who do we put first? We put arbitrarily in random order. If both of them are the same. Other questions? Okay. So please, review the material again before we talk next week on Tuesday. Thank you, guys. I'll leave now.
Thank you.
Bye-bye. Stop share.
Sir, I have a question.
Please go ahead.
Yes, I wanted to ask you, they asked you about the online quizzes.
Yeah.
Is the percentage on them less than the quizzes we had in class?
So it was, I think, no, it was maybe 20% and 20% or something like this. I don't remember, right? Check the syllabus.
Okay.
But we'll see whether we need to adjust the percentages or not. We haven't decided yet.
Okay, thank you.
You're welcome. I have office hours, by the way, right, from 12:30 till 2 today. So use the link, right? I'll send you the link for the office hours in a bit.
Okay, thank you, Professor.
All right, guys, if there are no more questions, I'll leave now. Pause, stop recording. Yeah, people are leaving, that's good.
You're gonna pause the recording?
I pause the recording or stop it? I stop it, right?